This conference will now be recorded.
All right, team, welcome back. And yeah, this is like a full stack DevOps practitioner training program, and this is the day one that we are starting, right? Uh, so we'll try to start with some of the very basics of the technical details today, right? And I will give some time for you guys to be flexible, right, with this course and the timelines. Okay, just to repeat some of the highlights, if anyone has missed my demonstration session, right, this course will go around 90 days, right, and Monday to Thursday 7 a.m. IST is what is planned for now, right, and so that you will get at least another 3 days of time in the week, right, to do some practice and explore more and come back to me with more questions, right. So that's the plan that we have as of now. Okay, and before I get started, is there anyone here who are completely new to the IT technology, like you are pretty much like a fresher where you don't have any IT knowledge? It could be any of other technologies, not just DevOps. Mhm. I see there is a hand raised there. Mhm. Right. Thanks for letting me know. Definitely, my course will start from very basics, where you don't need any prior knowledge in the IT. That is fine, but I'm just checking just to understand that how many people are here in the board, right? Having the complete like completely new to this technology. That just helps me that how we can drive this session. Okay. Probably I will be asking my admin teams to share with some of the links that you can fill up, which has the details asking your information, right? What technologies that you have already learned, right? What skills that you have already known, right? What is the current domain that you are currently working on? So these type of few questions will be there in the in the form. I'll ask my admin team to share with you guys. Just fill up the form. That is just for me to review who has already know which skill. Maybe I'll try to drive the sessions accordingly, guys, because if I know your current capabilities from the technical wise, that definitely helps me, right? Yeah, that's how it will be. All right. So, like, as part of this full stack DevOps practitioner training program, right? We are here to learn various bunch of different tools that are primarily important within the DevOps stack. Okay. So, at a high level, right, we are here to learn the infrastructure related technology stack and the security related technology stack and the monitoring and logging related technology stack and the containerization part where the Kubernetes is more important and the build and the deployment side of all, which will be like the Java application builds, the Jenkins pipelines and the automation stuff and the Git repositories, right? And these are the things like these are the total few high level the stacks that we are learning within this full stack, right? So yeah, definitely it's not easy, guys, to learn all of these and become expertise, but we'll try to have some disciplined learning strategies defined right throughout our journey. And as part of this, first I will be starting with the infrastructure stack. That's where we will be learning some of the Linux operating system basics and the AWS cloud technology, and how do we automate the deployments of AWS cloud resources using Terraform. That's our initial step. Once that is done, we will be moving ahead with the applications, right? That's where we will be learning more of the Java builds, right? The Git repositories and the containerization, and then we will be moving further, right? I think I have given enough details in the uh, demonstration session about the learning path and in which sequence that we are learning all these different tools, because I strongly believe that so learning will be easy only if we follow, or if we know that which tool that we need to learn first, which we need to learn next. That's how we need to understand the dependencies exactly. That is the main no, thing that helps us to learn so easily, guys. Okay, because we should know which is the basic to go into the next level of things, right? All these things. Being said that, quickly I will be jumping on to some of the technical terminologies that we need to be familiar with. Okay, so I'll try to drive this particular slide for today, guys. Okay, and as I said, in order to understand the complete real-time integrations, how exactly this DevOps is being used in the real time. So we are trying to use the online retail shopping portal application, right, as our use case to understand how the DevOps and the related technologies are being deployed in the real time for the applications like a shopping portal. So to get some real-time insights, right? So let's say if there is a real-time shopping portal application where you log into that website, shopping website, and you do a online shopping, right? Which has multiple features in it, right? So if you wanted to have, like, as a customer, if the customer wanted to, access the website to browse and do the online shopping, right? How that website is working, how it is being accessible. When you go and select the product and click on add to the cart, and then you do some credit card based billing, right? And your order is created and your product will come to your doorstep, right? What's happening in this whole process, right? How it is working, right? How the software technology is being involved, and what and all different teams are involved, what are those responsibilities to make this working. That is what we are trying to understand here, right? So yeah, so we'll take this online shopping portal application as a example in our whole course, right? And we'll talk about the technical challenges behind the screen, what needs to be done as a technical, I mean to say, as a engineer perspective, right? As a customer perspective, you already familiar, right? What is the feature of this particular web application? When you go to the website, order it, and you got a product to your doorstep, right? But what happening behind the screen, how a technical stack is involved, right? So what I can say, right? There is a infrastructure terminology that we need to understand here. When I say a infrastructure, the infrastructure is basically the hardware components that are collectively integrated together in the given data center, which we call it as a infrastructure. So pretty much the processor, memory, the networking cable connectivity between one system to another system, right? And having some hard drive attached to the systems. That's where, like, what does it mean by a simple computer or a system, right? Which has a processor, memory, the hard disk, right? The keyboard, monitor. That's a pretty much a system, right? And you all know the use cases of a system, right? Which will be storing some data and able to retrieve the data when it is needed, correct? So if you look at a high level, right? Let's say you bought a system, you bought a computer. what you do guys with your computer, right? At a high level, I would say you are storing some data in the computer and you are retrieving the data whenever you need it, correct? It could be playing the game, it could be writing a technical article, it could be creating a document, it could be watching the movie, whatever it is. For me, I'll understand like you are actually storing some data in the hard disk and use the data whenever you want it, correct? You save the movie file, you play the movie. You create a Word document, you read the document. You save the audio file, you play the audio, right? You are actually storing the data, you are using the data whenever you want it in a different manner based on the business use case. So here also same thing. I have the online shopping portal web application where my customers wanted to access my website to browse and purchase a product, and which is generating a lot of data, and I wanted to save that data, the customers transactional related data somewhere in the system, right? And that system has processor, memory, and the storage capacity, which is hard disk. And obviously, right, when it comes to the real-time based online shopping portal, right, having one system is not definitely sufficient to store the data of thousands of millions of customers that are accessing my website. That is where, right, at a broader term, we need multiple computers, multiple systems to manage the data of my multiple millions of customers, right, who are accessing my website, correct? So that to maintain the millions of customers data who are accessing my online shopping portal website, definitely I need multiple systems, as I said, and all these systems must be connected one to other, and all these multiple systems I will be putting it into one single place where it called as a data center. In simple term, right, basically let's say I need total 100 systems to manage my online shopping portal website related stuff. All the 100 systems I'll be putting in one single place, which we call it as a data center. And at a broader term, the computers and the connectivity, the required hardware, right? That whole stuff we call it as infrastructure, nothing much. So that means what? Now, if I decide that I need to build a online shopping portal where I wanted to run my business through, obviously first thing is I need a infrastructure. What does it mean by I need infrastructure? I need a hundreds of servers, right? And I wanted to keep all of my servers in a given space in single building, probably, which we call it as a data center now, right? So once we have the infrastructure ready, what does it mean by infrastructure ready, guys? Let's say I go and purchase hundreds of servers, and I'll put all of them in one single building space. I'll put some cable connectivity between the systems, then I'll make it ready, right? Once the infrastructure is ready, is not mean that that is ready or capable to serve the website for my customers. Because when I say infrastructure, mostly it will be like a hardware level configuration. You bought a hard disk, you bought a memory, like the RAM, you bought a processor, you bought all the hardware devices, right? Will not be working just like that. Sorry. You need a operating system installed on top of these hardware devices in order to start interacting with that to use them as per your use cases. And as of today in the market, as you see, there are multiple operating system flavors that are available to interact with your computers. The Linux flavored operating systems like Red Hat, Ubuntu, CentOS, Amazon Linux, the Windows flavored operating system, and Mac based flavored operating system. These are the some popular operating systems that we will be knowing, right? So any one of the operating system can be fine that can be installed on the given infrastructure on the given systems and use this operating system to start utilizing your computers for your business use cases, correct? Just simply put, uh, if you're completely new to this IT, right? For example, you bought a computer, right? You bought a laptop basically, right? If you have just a hardware, if you have just brought a laptop, you can't use it, right? I think these days when you go to the store and purchase a laptop or a system, your laptop or a system is coming along with the operating system is pre-installed. That's the reason most of the folks may not be aware of how to install the operating system, how to use it, because the systems are pre-equipped, with the operating system as well. You just buy it, open it, and start using it. But if you really look at few maybe years back, usually it's all like customizable in the sense when you order a computer, you get the computer as a hardware, bare metal hardware, and then you decide which operating system that you wanted to. Then you in the sense your store guys will load the operating system and make it ready, operational, then use it, right? What I'm trying to basically, operating system is must to be installed on the given computer before you start interacting with it and use it, right? So that means if my online shopping portal website to be running, the first step is we need a infrastructure to be ready. The second step is operating system must be installed and it should be operated, right? And for you to use. The third step is application has to be installed. Usually, the operating system is just the interface for a human for you to interact with the computer, right? But in general, the operating systems are designed as a generic, which can be handled any of the business use cases, right? So for which purpose you wanted to use your system, your computer, accordingly, you need to build your own application and install the application on top of the operating system and use it for your business, right? So in our context, when it comes to the business, right, because our requirement is what? Our requirement is to run a online shopping portal website, right, which can be used by my customers browsing on the internet browser on their own systems and purchase a product. That's my use case, right? So to make these type of websites to be accessible by the customers over the internet, right? Which applications that I need to install and operate it, correct? So some of the application names that I can call here is Apache HTTP, Apache Tomcat, Jenkins, Python, Java, Docker, Kubernetes, right? That means you call, you name it whatever the tool that you know as of today. Everything I'm just calling it as like an application. Each application has its own requirement, its own useful use cases, right? Each application is solving certain problems, right? So what kind of the use cases that we have, what is that we are going to achieve based on that you go and search in the internet and search for the product, search for the organization who is giving you the right product or right application for you. You download it, you install it, and you use it for your use cases, correct? For that matter, for example, you purchase a laptop or a system, guys, right? So then what you will be thinking of? In general, the moment when you get a new product, a new laptop, right, from the store, it won't be having anything in it, right? Except some basic operating system provided softwares. So if you wanted to start making use of your system, now you will think of what applications that I need to install. Search for the application, download it, install it, use it for your use cases. It could be a Microsoft Office software, right? Microsoft Office that you need to install in order to create your own documents. It could be a Acrobat reader in order to start reading the PDF files. It could be a printer software which will be printing the documents. It could be a scanning software to scan the documents. That means every use case has its own application, guys, correct? It's your responsibility now to install that application, make that feature available in your system and use it. So similarly here, the Apache HTTP is one application that has its own use cases, and it basically solves certain problems, right? And similarly, the Tomcat, Jenkins, Java, Docker, Kubernetes, and MySQL, right? Each has its own use cases. We should know the how do we install them, how do we configure them, how do we use them, what are the use cases of each and every application that we called here, and that's it, right? And these applications will be installed on the operating system, right? And once you have the application ready, then the end customers, whoever is accessing my website, right, that request will be actually hitting my applications which are running on the operating system, which is basically on top of your infrastructure devices. That means your systems, basically computers, right? Why I'm giving this slide, guys? Because you guys are here for the full stack DevOps training program, thinking that we will be learning the DevOps tools, and most of you will know that when it comes to the DevOps, we will be learning about Kubernetes, Jenkins, right? These are the some popular tools that you already familiar, thinking we will be learning these tools, right? But if you want to learn the Kubernetes, Docker, Jenkins, which are currently under the application section in my slide, you should know some basics of operating system, guys, because these applications are actually installing on the operating system. If you don't know what is operating system, you can't learn how do we install and use these applications. And to install and use operating system, you should know a little bit basics of infrastructure. That means some infra related knowledge, or else again we can't use the operating system basics, right? It has some dependencies, guys. That's the reason I will be starting my sessions start from infrastructure. You will get some idea about it. Then I'll move to operating system. We'll get some more idea. Once you have some flexibility about the OS basics, probably the next step is application section where we will be talking about Apache HTTP, Tomcat. Then we'll be moving, towards the advanced level tools. That's how it is. That means by the time we reach the Kubernetes Jenkins topics, it takes definitely a month of time, guys. So we should be ready for that. Any questions to me so far? Looks good, right? So I'll show you the data center, how it will be. In general, this is how the data center looks like, all right? So if you see this data center diagram, guys, what is data center? In general, the people will take a bigger space, right? And they put some number of racks, and in each rack, right, they put three or four or five, whatever the based on the size of the rack, right? They'll put the computers in it. That's it. So if you look into this diagram, it has almost 10, 10 to 20 different racks, and each rack can accommodate some number of computers. The same, whatever the systems that you know, right? Usually, the same systems will be there here. That's it, right? And this data center can, let's say, if this data center is accommodating almost to 200, 300 systems, then probably I'll make use of these 200, 300 systems to run my online shopping portal business. And the customers can access my website from the internet browser to do the business. and this data center is making that feasible to store and serve whatever it is needed from the technical perspective, right? So the thing is, let's say I wanted to start a business, okay, and an online shopping portal business, right? I want my website to be up and running. And what I'm saying, right, if my website has to be up and running and my customers come and purchase a product, I'm saying that we need a infrastructure, correct? We need a data center, we need a systems here, right? But it's not so easy, right, to maintain a data center, because if you are maintaining a data center like this, keeping the number of racks, put a cable connectivity, right? And obviously you need to put the power connectivity, redundant power, right? And probably the temperature conditions, maintain the good, air conditional things, and physical security, right? And what about the hardware failures? All of a sudden, due to power fluctuations, the hardware may go bad, right? Hardware warranty, right? And replace the faulty hardware with the good ones, right? So lot of challenges are there in maintaining the data center. So what does it mean, right? Let's say if I want to run a business, online shopping portal business, probably rather me as a business owner, rather me focusing more on how do I improve my product sales from the customer perspective. That's more important, right? I need to think of how do I improve my sales? What products that I need to put in my website? What could be the cost of the products? How do I give the discount for them? Analyzing the customer's behavior to give them the best product. That is where I need to put more focus, right, in order to improve the sales. But if you look at here, right, first of all, to run my website, I need a data center, and the data center itself is expecting me to put more concentration because of the hardware failures, the physical security, and the connectivities, a lot of things that we need to handle, right? That means I have to put more efforts on maintaining the data center, and I definitely not get enough time to think of my customer side of experience things or improving my customer thing, right? That's not good thing. That is where these days, when I said these days, right, that is where the cloud has come into the picture. What cloud says, okay, why do you worry about maintaining the data center and maintaining the servers by your, sorry, maintaining the systems by your own, right? The same data center will now be maintained by the third party organizations or the companies, and they will do everything for you, whatever is needed to run the data centers. You as a business owner just focus on how do you improve your business. Don't worry about the infrastructure. Let's say in this cloud computing introduction slide, right, this is what is called as a customer managed or on premises. What does it mean? If I need to run a online shopping portal business, right, as a business owner, I will be maintaining my own data center. I'll purchase the servers. Sorry, I'll purchase the systems. Again, systems, servers, both are same guys. Just that uh, whatever the system that you purchase to keep it in your home for your home related needs, that is called as a system. If the same system, if I put in the data center to solve my business use cases, the corporate world, we call it as a server, right? Because it is doing different, uh, it is solving the different problems rather the home-based problems, right? Use cases, right? Okay, yeah. So if I purchase my own servers and put it into my own data center, maintained by my own, then that is a customer managed infrastructure or on-premises infrastructure, we call it as, which has a lot of downsides, as I said, right? So the cloud has come into the picture. What does it mean? So the service provider will be managing the data center for you. The service provider is the technical terminology that I use here. Service provider is just a third-party company who is managing the data center for you. The service provider can be a Amazon, can be a Microsoft, can be a Google, can be any other company who actually manage the data center for you physically. If I take Amazon as an example, as a service provider, the Amazon is actually buying the servers, right? Buying the space for the data center, putting the servers in their data centers, put the connectivity, maintain the physical security, right? And the hardware warranty, everything that they manage, whatever the challenges are there in maintaining the data center servers, right? Everything is now handled by the Amazon as a service provider, right? And uh, the the servers or the systems whatever is required for me to run my online website, right? So that servers will now be accessible over the internet or over any of the network, right? And the the business can run there. If you see the second slide here, right? So in the customer manage, right? In the customer manage, me as a business owner, probably I will be spending more time. How do I connect to my servers which are in the data center? How do I use them? And how I can run a business to improve my sales? That is the portion that I need to be more concentrated on. I don't need to worry about the server's warranty, right? And the data center temperatures, AC, I mean to say the air conditioner thing, the physical securities, and any other challenges. I don't need to worry about it. Not only these things, when it comes to the data center maintenance, right, the very important thing is the scalability, guys. The terminology scalability means, for example, today I wanted to buy the servers for my business. How do you know how many servers that you wanted to buy? How do you know how many systems that you wanted to buy, correct? Of course, this question is definitely be there for the people who are purchasing a simple laptop as well, right? The next question would be, should I be purchasing a laptop with how much CPU and how much memory? How do you how do you validate, guys, when you are purchasing a laptop? You do some analysis, right? Probably, am I using it for my office? Am I using it for my home purpose? Am I watching movies? Am I playing the games? That's how you usually validate, right? Before you take a decision, how much memory that I would be required for my system, correct? But still, you can't take a optimal choice. You go with some number, but you may be over provisioning the capacity sometimes. You may be under provisioning the capacity sometimes when you are purchasing it. There are a lot of use cases where you purchase a very big system, but maybe you're not using much. Or you purchase with less capacity, later you found that it is not supporting for the game that you wanted to play. And it's not easy to go and upgrade the capacity, right? Hardware level. The same problems will be applicable when it comes to the business as well. Today you go and purchase one system with some memory capacity that may or may not be sufficient for your business use cases as the business will keep on growing. And if it is physical, it's not easy to go and upgrade it just like that. So when it comes to the cloud, I mean to say when it comes to the service provider managed data center, you don't need to worry about all of these. You just tell to the service provider company, let's say Amazon, that hey Amazon, I need a system with 100 gig of capacity. You just take it, use it for your business. Tomorrow, if you don't need 100 GB, tell that I don't need it. Again, you need it, tell that I need it. Whatever the amount of capacity that you are looking for your business mapping, you just get it, pay for the same. You don't worry about right. I mean to say it's easily scalable in nature, right? When it comes to the the cloud provided infrastructure. What is cloud here? Basically, that new term is coming up, right? So basically, the infrastructure is being managed by the service providers, which you are not directly dealing with that. That kind of the business nature is called as a cloud, nothing much, because the infrastructure is completely, you know, uh, completely not in your control. It is taken care by the different service provider companies, and you are able to access your services, I mean to say servers, and use for your business, right? That model is called as a cloud, nothing much. As I said, the service providers will maintain the security, scaling, elasticity, elasticity in the sense, for example, today you got some 100 gig hard drive for your business. Tomorrow, maybe you think that 100 gig is not enough. No problem. You go for 200 gig. It's easily scaling, sorry, elastic in the sense like it's easy to grow and easy to shrink as well. How much you want it, just get it and pay for them, right? All the difficulties, challenges required to facilitate all of these features will be handled by the service provider for you. That's what it is. That's how the differences comes between the on-premises data centers versus a cloud data centers, or on-premises infrastructure versus a cloud infrastructure, guys. Of course, the people are saying that the cloud is less secured compared to the on-premises. I agree, but as the time going, the people are preferring to use the cloud-based infrastructure because a lot of overhead is minimized when it comes to the cloud, and and the business owner is getting more time to think about their business rather thinking about the backend data center. So that is helping for them to improve their business. So and they're thinking, it will be more beneficial. So the recent days, the cloud service providers also giving more uh, s- tightened security things as well. So I think at least as of today, the security is not a concern anymore for the customers. That's the reason I think almost every business is moving to the cloud. That is where the cloud is got little more popular, and the skill is must for every engineer, guys. You may think it will be more theoretical today. Why we are not getting into some technical practical implementation? We can do that. We have enough time for that, but having some basic understanding of these terminologies and what is that happening. And also, when you're learning a DevOps, don't learn the DevOps as a technical concept or a technical manner. Learn the DevOps from the business perspective, guys. That's where I'm trying to map it from the business side of world. That's where I'm trying to use the online shopping portal app as an example, and I'm trying to connect the business to the technology. Any questions to me? All right. So I think by now you now understood that, right? Our next step is to learn about cloud infrastructure, right? And Amazon is offering the cloud infrastructure using their product called Amazon Web Services AWS. Microsoft is offering the same using Azure. Google is offering through like Google Cloud, correct? Out of all these different cloud platforms, so we are here to learn about the AWS cloud platform, how Amazon as a service provider, as a cloud service provider offering, sorry, infrastructure to you as a service using the AWS product. So that means in our next lecture, we will be get start with the AWS. How do we create a AWS account, and how do we get started with AWS to initiate our post AWS resource? and then we'll talk about how AWS is maintaining their data centers across the globe. Because as I said, the Amazon as a service provider is building their physical data centers across the globe, right? So how are they maintaining that, the different basics around it, and we'll log into the AWS and we'll start, preparing some basic infrastructure required for us, and then we'll move on to the next step as we discussed here, starting from cloud infrastructure, then the operating system, then the application layer. At the end, we will know how this, the online shopping portal web app will be running, which will be useful for my customers. That's the roadmap that we have, right? So any questions to me, guys? Because the day one, there's a simple theory that we have, and in the tomorrow lecture, we'll be get start with the AWS introduction. That's all for else we are good for today. All right, team, I don't see much questions there, and hopefully you are good on this. Thank you.
And tomorrow session, do we need to create a AWS account? Uh,
You don't need to create it, right, as of now. I think tomorrow I'll instruct what needs to be done. Yeah, at least by tomorrow end of the session, yes, we should have an account ready.
yeah. Okay. Could you please post that maybe this week the session coverage?
Yeah,
What is
sure.
that?
I'll be usually sharing the Excel like Google sheet where it has the day-wise topics what is covered. I'll be sharing the links in the WhatsApp group after the session, guys, in general.
Yeah. Thank you.
And the today session will be get uploaded to the Valaxy platform, the learning portal. So the admin team will be sharing the links where do you find the recording sessions, all these things in the group.
Yeah. Sure. Thank you.
Thanks.
For practicing, where do we get once we create the AWS account, right? So after that, like for Docker, Kubernetes, do we get any?
Right. So everything like Docker, Kubernetes, Jenkins, everything you do practice within the AWS account itself. Right. Mostly you don't need to install anything on your local, right? When I say local, on your laptop, it's just the internet browser. You access AWS, and every practice will be done on AWS itself, guys.
Okay. And then coming to Docker and Kubernetes, like are we going to learn like basic Docker file creation, container, containers, and like how the images are built? So all those basics we'll be talking about.
Yeah, definitely I'll be starting with basics, but out of the total number of tools that we are covering in this course, definitely there is some prioritization, right? Which tool that we will be covering the most, which is least, right? Because we don't need to put the same importance for all of the tools, correct? Based on the need, the job role, we need to prioritize. So out of all the tools that we have in the list, the Kubernetes is the topmost priority for me. That means I'll be covering the Docker and the Kubernetes to the extension level, and you get a lot of advanced learnings on those tools. That's my main focus.
Okay. Thank you.
Yeah, I'm seeing the chat window. Yes, the putty is needed. I don't consider that is actually a tool that we can install. So that's the reason I'm not worried much about it.
Like I'm basically like QA background, so from QA perspective, like for DevOps QA engineer, like what else we adding or covering in this?
Um, yeah, I think if you're already a automation QA engineer, then probably it makes easy for you to learn as well because you have a bit of coding side, some knowledge as well.
I mean, like Jenkins continuous integration and CD and CI, those things also will be like covering this.
Correct.
Okay.
Obviously, right? We'll cover the
Yep.
Jenkins CI/CD pipelines. How do we like when we get the Java code from the developer, right? How do we build it using Maven? How do we no, push to the Sonar queue for analysis, right? And then it goes to the next steps to build a Docker images. How do we deploy them to the Kubernetes? How all of these are pipelined using the Jenkins CI/CD pipeline, and how do we deploy them, start from the dev to the production, right? All this will be covered as part of this. And how are we securing our application deployments using the security tools, right? That's how it handles.
From the deployment perspective, like how to validate the deployment using any scripting, those things also will be we getting.
Uh, Basically, right, from the build and deployment perspective, the CI/CD pipeline is responsible, right, till it deploy the application, right? And as part of the build process itself, the usually the Java unit test will be taken care of to validate certain functionalities. And if you are looking at validating the deployment, that is post the CI/CD process, right? So that's all
Yes.
come as like a post scripts. When I say post scripts, we need to use the scripting languages like a Python and build a post scripts that can be executed to validate the APIs if they are working as expected. I'm using some technical terms just to give this answer. Others may not be able to understand it, right? So to go to that level, we need a Python knowledge at least to get start with. So as of now, we are not touching the programming language in this current full stack program because program learning a program is different thing altogether, right? Not like a tool learning. That's only the reason. But at least as part of the CI/CD workflow, you will understand the process side, how that is being taken care, but not the actual development of the scripts that we need.
Okay. Are we going to learn like Python basics at least?
No.
Okay. But I see in the curriculum there is Python as well. So,
Did I mention that too?
like in the website of Valaxy, I saw.
Sure. Like I was providing the Python basics as well as part of you know, as part of the DevOps itself, but the people were feeling the difficulty in learning uh, the programming as part of the DevOps itself because uh, in general, like for the beginner, right, learning the DevOps tools and then upgrading themselves to the programming all at one stretch is like too much for the people. That's what is the feedback. So then we splitted it into two different things. One, you first learn the DevOps tools and be expertise there. If you are comfortable there, then the next step you start with your Python or programming journey. That makes the people are easy. So usually what I did, right, I separated it out the Python sessions next, and whoever is interested to learn that. So as part of the same subscription that what you paid for the full stack DevOps, right, I will be offering the Python courses in whatever the way that it is flexible for them, right? That's how it is handled actually. So as part of that, I think I might have been removed it from the current full stack one, but I can verify if what which content or which index is being shared with you guys.
Sure. Got it.
Hi, Pierre Reddy. Am I audible?
Yes.
Yeah, okay. I actually come from a non-IT background, but I've actually taken a course uh, regarding AWS DevOps previously, but I couldn't attend the classes after the Terraform subject. So I have attended two or three interviews. So they've been asking, do you have any knowledge on scripting, be it bash scripting or Groovy? For example, of mentioning this. So, can we expect any basic uh, teaching from you on the scripting thing?
I think yeah, the same answer goes to you as well, right? So the thing is, even in the demonstration session, I said that the scripting is required. I'm not denying that, and there are a bunch of tools that we need to learn as part of this DevOps program, right? Starting from the infrastructure knowledge, right, and then the operating system, then the tools like Docker, Kubernetes, Jenkins, MySQL, right, Prometheus, Grafana, and the security tools, Sneak, right,
Hmm.
Terraform, AWS. There are many, right? So
Yeah.
the people are facing difficulty in catching up all of these tools. On top of this, the programming, right? Lot of that's the reason, right? As I said, I'm not including the program as part of this DevOps itself. That is separated it out. So yes, I'm teaching Python as well, but not part of this program that is separated. If you're interested, yes, we can get that as well.
Okay. Got it. Thank you.
Mostly what I observe, right, the people who wanted to start the journey, they are completing the DevOps, take a
Mm.
breath of 1 month or 2 months to digest the content, learn it, expertise it, and get some confidence on these concepts, DevOps concepts. Then they
Mm.
take initiative to learn the programming side.
Okay. So, according to you, after completing this 3 months of course, with of course our individual practice as well, how much years of experience do you think we can update it on the resume?
I'm sure you can update 5 to 6 years of experience.
Okay. Okay.
All right, team. Then, if no questions, we are good for today. We'll see you tomorrow.
Yeah, hi sir. So may I know the duration for Python course?
The Python alone will take, I think, 25 days. As of now, I don't have any dates specific to just the Python course yet, and you can get more details from admin. But the Python alone can be learned and can be completed within 25 days.
Thank
Thanks, guys. See you tomorrow.
Thank you, sir.
Thanks. So as I said, right, who is interested on Python? Yes, we can give my previously conducted Python recordings as well, part of this DevOps subscription without no cost. Thank you.